Now, while we've talked about a bunch of different types of histograms, we're going to be focusing on one in this video that is symmetric and unimodal, such as the one before you. We're going to be talking about specifically what's called the normal distribution, and I want to be very clear before we go on that not every histogram that looks like this, not every histogram that's unimodal and symmetric, actually constitutes the normal distribution. However, this shape, that is, ignoring the bars and instead drawing a curve over the top of it, this shape is a very helpful shape to have. So let's go ahead and get rid of the bars and look just at that red curve. So what I've gone ahead and done is replace that really rough histogram we've had with this really nice smooth bell curve that would have sat on top of it. Now let's go ahead and talk about what's going on here. And the most important thing we can realize right off the bat is, once again, it is symmetric and unimodal. That's a key to what we're going to start calling the normal distribution. It's not the only important property it has, though, and we must realize that not every bell curve constitutes the normal distribution. The normal distribution also has another really helpful property, and this is what we call the 68, 95, almost all property. And to understand what it means, what we're going to do is we're first of all going to add in a bar in the very center of our histogram, and then we're going to go one standard deviation on either side. Now, if this actually meets the normal distribution, then what happens here is that if I start at the center and I get one standard deviation up and one standard deviation down, then it turns out the percentage here in the middle is set. That is, in between one standard deviation below and one standard deviation above, I find the middle 68% of people. That is, 68% of observations will lie between one standard deviation below and one standard deviation above. Our next step is to go ahead and add in one more standard deviation on either side. So on the lower end, I have a bar that's 2 standard deviations below the center, and on the upper end, one that's 2 standard deviations above. Now, if you're paying attention to the rule we're looking at here, it probably makes sense then that if I go between one standard deviation below and one above, I get the middle 68, and if I go 2 below and 2 above, in between there, I get the middle, you probably guessed it, 95% of all data. So I've got the specific property to my distribution. 1 above, 1 below, 68, 2 below, 2 above, 95. Well, there's one more piece of information we come up with here, and at this point you could probably guess it. And that is, if we add in our third standard deviation below and our third standard deviation above, then, well, we can go ahead and we can highlight all of this. And as you can guess by the rule itself, but also by the drawing, that is, if I go 3 standard deviations on either side, I have almost all of my data. Now this makes a really important part of the normal distribution, and that is, when we go 1 standard deviation out, we need to have 68%, 2, 95, and 3, almost all. What that tells us is, if you look at these tiny little end tails on the upper and the lower part that are not shaded, there's basically nothing out there. And what this tells us is observations that fall more than 3 standard deviations away from the center can actually be considered to maybe be outliers. And this brings us into our final property about the normal distribution. This is what's called the 3 standard deviation rule. The 3 standard deviation rule tells us that if an observation lies more than 3 standard deviations away from the center, it can be considered a potential outlier. Notice the emphasis there, right? I didn't say it's actually an outlier, I said it's a potential one. We're going to learn better ways later on to really detect, well, is something far enough away from expectation to say, something's going wrong here or not. So in review, a normal distribution is symmetric, it's unimodal, but it also has this whole 68%, 95, almost all property. And when we have a normal distribution, we can call something a potential outlier if it's more than 3 standard deviations away from the center.